Another thing I want to talk now about is the other difference between the worlds. How many different kinds of units are used around the world?
A whole bunch.
A whole bunch. But there's three main categories. One is called the other one is called, and the last one is called, and so apparently are engineers. So anyone want to guess what MKS stands for? Done. Anyone want to guess what CGS stands for? Oh, so let me just write this down. So it's meters, kilograms, seconds, right? C stands for, G stands for, and S stands for, yay. Anyone want to hazard a guess of what the US engineers use?
Inches.
No, one more. Go higher than inches. Feet. And pound mass. And
Minutes.
no,
Hours.
no,
Seconds.
seconds. That brings us to your worksheet. Question 1. Okay, I will stop talking now and let you guys struggle through this. You can talk to each other. I promise I will not look at the answers. I will not come around, but you have exactly 2 minutes.
Do the first two questions?
No, this is the first one.
Okay, I was gonna say the entire page. Okay.
No, just the first question. 2 minutes. I will start doing it too. Let's see if I can get it done. No one look up.
Okay. Everybody look up.
Pick a color, guys. Pick
Purple.
purple.
I like dark blue. Those are fun ones. Next one. Do we have to hand in the worksheets when we're done?
No, not today.
Almost. Not yet. I write gas on the board. I get here.
Okay. So 55 miles per hour. How many meters in a mile? Times how many seconds in an hour? An hour gets canceled. Miles get canceled. Somebody do that math for me. It's going to be 55 times. Oh, now you're supposed to look up.
Don't forget the decimal point.
Well, I'm doing miles directly. I didn't do kilometers.
Oh, you're valid.
I skipped a step, sorry. Anyone want to give me the
I
answer?
don't think it's conversion, but it's okay.
Wait, oh, and meters on this. Anybody want to tell me the answer?
I got it.
24.5
Okay, rule of thumb, never go beyond 1 or maximum 2 decimal places. I know they always talk about sig figs and blah, blah, blah. I don't necessarily care about those necessarily. Just a rule of thumb, approximate it to maximum 1 decimal place. But if you're going like thousands, I would not even go 2 decimal places. I would just stop at 1. So if your answer is 10,048, don't do 0.444, right? Just,
And physically.
yeah. That's pretty much a good rule of thumb. Maximum 2 decimal places, even 1 is good. not that there's anything wrong with it. It's just that there is no way for your calculation to be that correct to that precise number, right? Because if you're doing 10,000 something, the tools you're using are too big for you to get that answer. Okay. Okay. So does anybody want to do? Oh, did we all get the same answer? Do we all know how we got it? Bobbleheads? No? Yes? Yes? Okay, excellent. Okay. So what happens in situations where everybody's using a different unit?
We don't get money.
Bad things happen, right? And that was one of the concerns in the 17th century when people started to talk to other people. Communication became easier. So they were like, there has to be some standard that we can use. So what they started to do was what is now known as, drum roll please, so the first person who came up with this scheme in 1822 was Fourier. You will hear this name a lot when you go into upper level physics classes or math classes, right? And he came up with this scheme of, instead of using units, he used symbols. So for mass, instead of worrying about whether you were measuring in kilograms or grams or foot pound, like whatever you were using, he just said, I am going to measure my mass as m. Instead of worrying about length being measured in feet or centimeters or kilometers or miles, I'm just going to call it L. Same thing, he said for time, instead of worrying about seconds, minutes, hours, there was no standard at that time. So he just said, I'm just going to call time as T. And that's it. I don't want to use any other units. I don't want to use any other units for this. There's a problem. We have other units. For example, newtons. Newtons are a unit of? Excellent. Joules are a unit of? Or work, right? Excellent. Watts are a unit of? Good. And they're all connected to each other, right? Newton meters is a joule. Joules per second is a? Excellent. So they're all related to each other. So how can just using these simple figures be enough to explain everything? Here's where the magic happens. So for example, if I wanted to find a position of a particle, that's easy. Position, how do I write this? Okay, position is just x or delta x. Does everybody know what delta is? Excellent, change. So delta x means in position of a particle, right? A spherical cow. A change in position is x, delta x. So in dimensional analysis, what do we call this? Excellent. What is velocity?
Speed and dimension.
Agreed? And yes, it has to have a thingy at the top. How do we write this as dimensional analysis when we are doing dimensional analysis? Do you see it? It doesn't matter what x is measured in, miles, kilometers, meters, centimeters, millimeters, micrometers, nanometers, whatever it might be, right? It's always written like this. Okay, so what is acceleration? Anybody remember?
You change the velocity.
Does everybody recognize d squared x over dt squared? So how does dimensional analysis deal with that? Note, it's d squared x over dt squared. Yes? So there's only one x. It is the second order differential, right? So remember, in a second order differential, right, for you guys who have not done differential equations yet, when you write this number, when you write this down, that means that it is the second order differential in time. Okay, that x is just alone. Make sense? And for those of you who have done differential equations, just a reminder, yes.
So it's just derivation twice.
Yes, it's the derivation over time twice. But x does not get changed. I mean, x does get changed, but with respect to time. The other second order differential sometimes that you will see is over x squared. Right? That could also happen. So for example, it will be like an omega over dx squared or something like that. Like a variable over x squared. That means it's a second order differential in position. So when you are going to do this, you have to do it twice. That is why when you're writing dimensional analysis, this only has one unit. This only has meter, for example, and this has time to the power twice. Excellent. Now, what about force? If I was to ask you to do force, the unit of force is newtons is defined in terms of basic quantities. Oh, what is sigma F? What's Newton's second law? Sigma F is ma. So what is the units of newtons? What is m? There we go. Good job. Right? Do you see how these things become important? So what will be the dimensional analysis of Newton? Kilogram is m, meters is L, time is, and raised to the power. Woohoo. So as a dimensional analysis problem, you write force as MLT minus 2. Got it? Okay, now let's do a problem.